got forced vibration at depth of 2 degree of system automobile simulation rig, which is the simulation of animation of operation of real world process over time. As we all know, we have 2 degree of system is the independent coordinate required to define at any point instant position of different position in the system. Okay, now let's move to the objective. The first objective is to find the natural frequency with different speed measured in RPS, and the second objective is to find the amplitude ratio and sketch the mode shift.
I will explain to you about the theory of the 2 degree of freedom automobile simulation rig. First of all, why we call it the 2 degree of freedom? Because it involves 2 motion, which is the translational part and the rotational part. The translational part is about the movement of the x-axis about the center of the mass, and the rotational part is about the rotation about the center of the mass. Then I will explain to you about the rig. The rig is mainly is built from the rigid bar and the spring. This rigid bar is for the body of the car, and the spring is for the suspension of the car. We call this as the L1, which is the 11 cm, and this part is the 19 cm.
Okay, in this part, I will explain about the experiment, which is what are the sensors we use and the procedure for the experiment. In this experiment, we will use 2 types of the sensor, which are accelerometer and the tachometer. This is the accelerometer. Accelerometer is most widely used vibration transducer for measuring vibration on stationary machine element. The second sensor we use is a tachometer. A tachometer is an instrument to measure the rotational speed of a shaft or disc for this experiment. Okay, next we move to the Desired setup. Firstly, we need to connect the sensor with the natural instrument. This is the national instrument. Every sensor we will connect to this device to the laptop. To connect the device, we need to select the acceleration 0 for sensor accelerometer 1, acceleration 1 for the sensor accelerometer 2, and the voltage for the tachometer. Then we need to change the sensitivity for each sensor. Then we move to the Desired setup. The data from the NIDAQ is synchronized with the Desired setup. Firstly, we need to do scaling to remove error, and we use 2 filters. The first filter is low pass and the second filter is high pass in order to reduce the noise. The objective of this experiment is to find the natural frequency with this different speed RPS. We use FFT to obtain the natural frequencies. The speed of the rotation of the motor is increased to get the difference value for natural frequencies.
I will present about the result and discussion of this system. Okay, for this experiment, we got 2 objectives. The first objective is to find the natural frequency of automobile simulation ring with different speed of the motor. The second objective is to find the amplitude ratio and sketch the mode shape of the automatic simulation ring. This is the result we obtained from the Desired setup for objective 1. Based on the overall result obtained from the experiment, we can observe that the natural frequency increases as the rotational speed of the motor is increased from 20 to 50 RPS. The natural frequency increases because as the rotational speed of the motor increases, the rotational force of the motor increases, and the force of the system make the system vibrate more frequently. We can conclude that the natural frequency of force vibration system is depend on the force applied to the system. The Desired setup, we only got the frequency data. So we convert the frequency data into natural frequency to get the natural frequency 1 and natural frequency 2. For example, the sample calculation for speed 20 RPS is omega 1 is equals to 2 pi f equals to 125.6 radian per second. The graph of natural frequency 1 versus speed of the motor, and this is the graph natural frequency of 2 versus speed of the motor. We obtain from DesiLab setup for objective 2, which is to find amplitude ratio and sketch the mode diagram of the automobile simulation ring. From the data we can see, we find the amplitude ratio of A1 over B1, amplitude ratio of A2 over B2. The amplitude ratio A1 over B1 and A2 over B2 decreases as the rotational force of the motor increases. The amplitude depends on the frequency of the system. The qualitative data F error. From table 2, we can observe that both natural frequency omega 1 and omega 2 have the same value. But based on the theoretical study, we should get two natural frequency which have a different value from each another. Okay, the amplitude ratio is affected by the natural frequency. Because of the same value of omega 1 and omega 2, we get the same amplitude ratio A1 over B1 equals to A2 over B2. The reason for the error in the data obtained is maybe because of the high stiffness of the spring and a very light mass of plastic body we use for the system. The spring has a stiffness of 34,375 Newton meter, and the plastic body mass is about 68.03 Newton. When compared to the stiffness of the spring, the mass of the plastic body is very small. The mass of the plastic body does not much affect the system, which causes the natural frequency of the system is almost the same regarding the position which we place the sensor.
Okay, based on this experiment, we had achieved the first objective, that is to find the natural frequency of the automobile simulation with different rotational speed of the motor RPS. Using the result that we have obtained, the graph of natural frequency, again speed of the motor, we upload. Okay, the graph show that the natural frequency increase as the speed of the motor increase. We also had achieved our second objective, to find amplitude ratio and the sketch the mode shape automobile simulation ring. Using the natural frequency from the objective 1, we had find the amplitude ratio and the sketch the mode shape of the system of very natural frequency. That's all from this experiment as a conclusion.